All right. So we're actually going to break quadratics up into 2 units. One of them is going to be quadratics that are in vertex form. The other one's going to be quadratics in standard form. But they have a lot of similarities. So today we'll talk about what is a quadratic, what is the shape of a quadratic. We'll talk about the key features of a quadratic graph, how to sketch one. That's our main objective today, is drawing a graph of a quadratic. We'll also look at how to evaluate, like plug numbers in and get answers, just kind of being careful to pay attention to some order of operations stuff there. Also, we'll talk about how to find the y-intercept. So, all right. So, what is a quadratic function? It's a polynomial where the highest power is a 2. We're going to be working in Unit 6 with this kind of a quadratic. That's called vertex form, and you'll see why they call it that shortly. But we'll do standard form next unit. So, a couple weeks from now, we'll talk about quadratics there. But they both have a highest power of 2. For the vertex form, it's here, and for the standard form, it's here. But that's what basically makes a quadratic, is that highest power is a 2. All right, so let's go ahead and complete this chart and draw a graph. So I'll do the first one just to kind of show you what I mean, and then I'll let you guys do the rest. So I've given you a table here with a set of x values. What we're going to do is we're going to take the x value that I give you there, and you're going to plug it in for x. So I'll plug in -2. Now -2 to the second power, that means -2 times -2, which is 4. So I get 4. And what that is that's a point. So I'm going to plot that point. -2, 4 goes right there. And I want you guys to do that for the rest of them there. So I'll give you a little bit. Go ahead. You don't have it? All right, just go ahead and do it on the back then. You know what? I wonder if I gave you guys the right set of notes. Let me see your notes. I wonder if I gave you... I might have given you the wrong one. These ones might be for tomorrow. These are for tomorrow. I gave you guys the wrong ones. Let me give you guys today. Sorry about that. My bad. Why don't you guys keep those, though, for tomorrow? Go ahead and keep those for tomorrow, because we're going to use them for tomorrow. Once you guys get this little handout here, you can go ahead and start the graphing thing, because it is on here. But keep those other notes for tomorrow. Put them somewhere. Yeah, but for in case someone else needs it tomorrow. Oh. Yeah, this is going to be for tomorrow. Okay. All right, so I'll give you guys a little bit of time to finish that chart there and graph it up, and then we'll come in. Okay, let's see what you guys got out there. So, Leah, what'd you get for this first one here? Okay, good. Did you get all of them? Yeah. Okay, can you just tell me all of them? 0, 1. Great. All right, I'm going to plot all those. So we have the first one I plotted earlier, then we have -1, 1, 0, 0, 1, 1, and 2, 4. And we get this graph. Now, it just keeps going, but I stopped at the 2 4s because I didn't want to do more than that. But just to show you guys what a quadratic looks like, this is what a quadratic graph looks like. It looks kind of like a U shape. Once again, this is something you probably saw in Algebra 1. Nothing too new there. But we're reviewing it now. So, I wonder if there's more information here. Let's see. I'm going to jump up to this first. So, just so you guys know, the graph of a quadratic is called a parabola. There's a few key parts of a parabola. This part down here, and you guys should label this with me, is called the vertex. Where it touches the y-axis is called the y-intercept. Where it touches the x-axis, those have different names. You can call them x-intercepts, but they're also known as roots or zeros. So they have a lot of different names. I don't know, does zeros have an E at the end of it? Put an S? I'm not sure. All right, so zeros, roots, or x-intercepts. All right, so those are the names of those particular parts of the graph. Those are what I call the key features or the important parts of a parabola. They're useful for like story problems. The y-intercept and the roots kind of tell you some things. The vertex tells you some things. Also, they're helpful for graphing because if you know those pieces, then you can kind of get a pretty decent sketch of your graph, which we'll see later on. But those are the key features of a quadratic function. Now, let's review transformations a little bit here. Now, we saw earlier that the graph of a quadratic looks like this. So what are the coordinates of the vertex? 0, 0. Good job. So my vertex is here, and those coordinates would be 0, 0. Now, as you guys may recall, what is this number, or what does the h do to a function? It moves it. Which way? Left or right. And this one moves it to up or down, right? So this one goes left or right. If the h is positive, it moves it to the left. If the h is negative, it moves it to the right. If the k is positive, that moves it up, and if the k is negative, that moves it down. Oops. All right, what else do we remember here about? How about the a? What does the a do to the graph? It can flip it, right? And that's really the only one we care about. It does other things too, but that's really going to be the only one I look at. If a is negative, we're going to flip it upside down so it looks like a sad face. But if a is positive, we'll leave it like that, happy face. Okay? That's the only one I care about. The other things that a did was it stretched it or it compressed it. We're not going to get into that today. We don't need to. Our goal for today is to graph these things, and we're not going to get that specific with how much to stretch them or how much not to stretch them. We're just going to basically want to know where they located by looking at the h and k, shifting them around, and also whether it's a happy face or sad face, and I think that'll be good enough for today. All right. Now, what was the vertex was 0, 0, right? So if I were to move this h units over and k units up, like let's say it was, don't write this, but let's just say I had a 2 here and a 5 here. I would go 2 units to the right, and I would go 5 units up. So the vertex will go over 2 and up 5. The whole graph goes over 2, up 5. But what's interesting is, what's the vertex now? 2, 5. So in other words, because of these transformations, and because of the fact that this was 0, 0 to begin with, these basically just tell you the vertex. So let's write that. This is an important thing to write on your notes for today. Vertex. What you want to know is that these two numbers put together make your vertex, basically. They're really just your translations, but because of the way it works out, they basically just we'll make it like our starting point. That'll be our vertex, our starting point. An important thing to remember is, though, is that this one's always going to be the opposite sign. So this is confusing, remember, like negative h. Wouldn't you think that means we go left? But it doesn't, right? Negative h means we go right. So whenever you're doing this, you have to remember to make the h an opposite sign. Okay, but not the k. The k doesn't do that, just the h. Just the h. All right, so we really only need 2 things to be able to graph them when they are in this form. When quadratics are in this form, we really only need 2 things. We need to know what's the vertex, and is it a happy face or sad face. The rest of it we don't really need to know. But if you know where the vertex is at, and you know if it's a happy face or sad face, you can get a pretty good sketch of the graph. And that's pretty much what we're going to do. All right, so we already talked about this slide. Sure. I can go back. No problem. That just means I get a coffee break. All right, I think we're move it along. We already did that one. So here's our steps for graphing today then. We're going to plot the vertex. So whatever these numbers are, those make up your vertex. Just don't forget that the h value will have an opposite sign. And also, once again, kind of like when we did absolute value functions, if the h or k are missing, they equal 0. So if there's no h there or if there's no k, we can assume that they are 0. If a is positive, that makes a happy face parabola. And if a is negative, that reflects it, so it ends up being a sad face parabola. If the a is not there, it equals 1, and that's all we need to know. So sometimes they won't have an a here. They might have a negative, so that means it's a negative 1. But if they don't have anything at all, it just means it's a 1. All right, so I think we're ready to start graphing a little bit. Did you guys get all that? Because this is really, the only thing you need to write is the parabolas there. That, the rest of it was just me underlining things. All right, so let's do some graphing. Example 1. So I'm going to do 3 graphs here. You could try to squish them all in the box if you want to, but just know you're going to need some space for 3 graphs. All right, here we go. So step 1 is to find your vertex. So what is the vertex on this one? 4, 3. So it's this number, but we do the opposite of it. And then it's this number, but the way it is, it stays positive. So we do the opposite of this number and keep that number the same. That's my vertex. Okay. Step 2. What number tells me whether it's a happy face or a sad face? The a does, right? Now that's a positive number, so what does that mean? So to get a sketch, and we're just kind of doing a real rough sketch. We're not being real precise here, but we have enough to kind of get a pretty decent picture of the graph. So I can plot this vertex. I can go over 4, up 3, and then we know it's going to be a happy face, so I think that's good enough. Only for H. Only for the H. All right. Let's go ahead and take a look at number 2 here. That's the first step, and then you will happy face based on this. Okay, so I'm going to ask you a question, and then I'm going to call on you to share out your answer for this one. So, for number 2, we're missing something. So, what letter are we missing? So, are we missing the A, the H, or the K? I'm going to ask Lily. What do you think, Lily? We're missing the K. And then I'm going to ask another person, just because I want to give out some points. Crystal, if the K is missing, what does it equal? It's 0. But can you say it with more enthusiasm? I'm just teasing. All right. So I'm gonna go ahead and squish a little +0 in there like that. You don't have to do that if you don't want to, but it is 0. All right. So go ahead and think about for a second. What's the vertex? What do you think the vertex is? Alonzo, what do you think the vertex is? Okay. Maya's not with us either. Armani, what do you think the vertex is?
-2, 0.
Good. So it's this number, but the opposite of it, followed by this number. So I agree, -2, 0. All right, next question. Cal, what's the A value on this one? It's a -1, right? So Jedrick, happy face or sad face? I agree. So see if you guys can do a sketch of what you think that would look like. All right, so it should have looked something like this. Something like that. All right, I want you guys try number 3 there. Try to do the whole thing there, and I'll give you guys a couple seconds, and then we'll call out and see what you guys got on it. Try number 3. It's missing some numbers. So you got to think about what's missing. So the A is missing. I'm just trying to figure out where we're at. Yes. It's not.
I wasn't here for this observation.
What's her name?
Ito.
All right. So let's see what you guys have got here. Cynthia, I think you have the hardest question. What's the vertex? Okay, good. So you know there's a 0, there's a 3. But that is not the vertex. But your 3 and 0 are part of it. Well, you want to take a crack at it, Steve? It's 0, -3. So let's see why it's that. So notice how that 3 is not in parentheses. Since it's not in parentheses, that means it's a K. So what we got here is the H is not there. The 3 is the K because it's not in parentheses. And the A is 1. So if it helps you to rewrite it like that, go ahead. But yes, it's 0, -3. All right, so now let's go ahead and graph it. But before we do, I'm going to ask Aaliyah, happy face or sad face? So this number is positive. That's a happy face. There you go. So that's that graph. All right, so I'm going to let you guys work on the student practice now for a little bit. I'll call people up to draw their answers on the board for us. Here is 1, 2, and 3. So go ahead and do those 3. I'll give you guys about, I don't know, 5 minutes-ish. We'll see how long it takes. All right, guys, so that's graphing quadratics in vertex form. We're going to move on to evaluating. Bonus question. What does it mean to evaluate a function? Actually, it doesn't mean to solve it. It's similar to solve it, but it means something else. That's part of it. I'll give you a point for that, but a little bit more. Mm-hmm. Mm-hmm. Yeah, we talked about it back, I think, in lesson or unit 2. It's been a minute. It basically means you're going to plug a number in for x and get an answer and simplify it after that. So plug a number in for x and simplify. So that's what we're going to do here is we're going to evaluate. So let's take a look at this one. Evaluate the function at the indicated value. So I'm giving you a quadratic function. Bonus point. How do I know this is quadratic? Raise your hand. How do you know it's quadratic? Go ahead, Edwin.
The highest power is 2.
They've got a power of 2 there. That's a quadratic. So evaluate the function at the indicated value. So I'm going to plug -7 in for x. So here we go. Yeah, the one on the left is just for decoration. But yes, we're plugging it in for both places. So I'll use a different color to emphasize that. So I'm plugging in -7 for x here and here. All right, now you got to remember your order of operations. What comes first when you're simplifying? Parentheses. So what is -7 plus 4? -3. All right, what comes after parentheses? Exponents. Good. So that would be -3 to the second power. That means -3 times -3. +9, right? Because when you square a negative, then the negative cancels itself out. What comes after exponents? Multiplication or division. In this case, it's just going to be multiplication. -2 times 9 is? -18. And after that, it's just going to be addition or subtraction, depending on whatever's there. So we have -26, yeah. There you go. That's it. We're just plugging numbers in, getting answers, but just wanted to review order of operations with you. So parentheses, exponents, multiplication, and then, or like you said, it could be division. That would happen if you had like if this number was a fraction, like a half, multiplying a half is like dividing by 2. But so PEMDAS, right? That's basically what we're doing here is PEMDAS. Okay, so there's a student practice, I think, for y'all. I'll leave this work up here, but this is the student practice problem. Go ahead and see if you guys can work that out. I'll give you a second. Some math races here to see if we can do the mental math fastest. The answer? It's not what I got? No. You doing your mental math? Good. I encourage you. Huh? Check your answers with someone. We'll see what you got in just a sec. All right, Shakir, what'd you get? Equals what? 21's right. So I'll show the work, but you should have gotten 21. So we're going to take this 5 and we're going to plug it in for x, so that will look like this. Parentheses are first. Okay. Okay. Then we do our exponent. And then 16 and 5 makes 21. All right, we're going to move on. We're going to find the y-intercept next. All right. We know something about that point. What do we know about that point? I know something. So we have a 0. Okay, we know 2 things then. One's 0, one's negative, right? Now the one I really care about is the 0 one. One of these is 0. Which one's the 0 one? Good. All right, so this is called a y-intercept, where it touches the y-axis. And that fact tells us how to find a y-intercept. To find the y-intercept, we should plug 0 in for x. If you plug 0 in for x, then you'll find that other mystery number there, and you'll have your y-intercept. And that's how you do it with any function. It doesn't matter what kind of a function I give you. You can always find the y-intercept that way by just plugging in 0 for x. Okay? So have you guys got that copied down? All right. I see a few pencils moving. I'll wait a second. Plug 0 in for x. So that's how you find a y-intercept. Plug 0 in for x. So here's a quadratic. I'm going to ask Miles, how do I know this is a quadratic? Because it's a power of 2, so I know that's a quadratic. And I know that if I were to graph this, Stephen, what would it look like then? Like what shape would it have if I graphed it? Like a U shape, right? And I'm just throwing points out there for review here. Denise, what do we call that U shape? What's the name? It's called a parabola. Okay, so anyway, that's old stuff, on to the new stuff. How do you find the y-intercept? Well, we said to find the y-intercept, you plug 0 in for x. So step 1 then would be to plug 0 in for x. After that, guys, it's just like evaluating. You're going to follow your order of operations. So we do the parentheses first. 0 plus 4 is 4. Then what do? Square it. Now this, yeah, so that you could think of it like a negative 1 in the front, but all it's going to do is just make the 16 negative. All right, so that's my y-intercept. That's where it will touch the y-axis. It'll touch the x-axis or y-axis at 0, negative 24. Well, we picked the x. We made the x 0. All right, so there's one for you, and that'll be it for today. So find your y-intercept, and we'll be done. What? Let me see. I don't have a lot of them, but I might have one. I do. Thank you.
That was the worst one.